Hi, I'm Mark Ashcroft. I'm here at IMS in Boston this year, 2019, in Boston, Massachusetts. We're here with the 9404 5 GHz SXRTO. Quite an exciting oscilloscope, a new architecture, and at a price just a tad below $15,000. A new architecture that achieves a rather lower cost for a 5 GHz 4-channel oscilloscope. As you can see, I've got on the screen here, I've got from our pulse generator, the PG900, I've got a fast rise 50 picoseconds, a fast fall 50 picosecond edge. I've got one on channel 3, one on channel 4. And I'm subtracting the two from one another to get a narrow pulse. And the narrow pulse allows me to demonstrate the zoom factor. So the little zoom window there is enlarged for us on the right hand side of the screen. So what we're looking at there is 50 picoseconds per division. We're sampling that form at 1 tera sample per second. And as you can see, we're doing that with really quite low jitter. Jitter of the order of 1.5 picoseconds RMS, typical. Certainly should be less than 1.8 guaranteed. If we take a look at some of the measurements that I can make here, I've got positive width being measured, I've got rise time and fall time being measured for this pulse. And you can see that the software conveniently displays all the mesials that I've got associated with that measurement: the top, the base, the 90, the 50 and the 10% mesials. I can control those mesials. I can simply grab them, pull them up and down. I know that in the scientific world we quite often see pulses measured at the 30% mesial, and you can see I can do that. That can be set quite accurately in the menu. And now we have a pulse width of about 160 picoseconds being displayed here. The mean over time, let's just clear the mean. And what have we got? We've got about 162 picoseconds there as the mean. Another little interesting demonstration I can do here is to, let's pull up a slightly different setup. On this setup, I'm bringing into channel 1 a signal from our Agile synthesizer. I'm bringing in a little burst of 1 gigahertz sine, then 2 gigahertz, 3 gigahertz, 4 gigahertz, 5 gigahertz, 6 gigahertz. And there you can see, in effect, the gentle roll-off of the bandwidth of this 5 gigahertz oscilloscope. The AS108 is generating that pattern. The pattern duration is about 5 milliseconds per division. Yeah, just over 5 milliseconds that pattern at the moment. On the bottom here, into channel 2, I'm using the second AS108. The two synthesizers have been synchronized together. That's one of the important facilities on the AS108. We can synchronize multiple units. So down here I'm generating a little burst of 2 gigahertz carrier. What we want to try and do is make some measurements on that burst, but we want to make measurements on the envelope there, rather than the carrier that we're displaying. What I can do is I can put this into envelope mode, and now the oscilloscope is tracing out the envelope of that carrier. And you may be able to see now down in my measurement window on channel 2 I'm measuring a pulse width of 6 milliseconds, sorry, a wave period of 6 milliseconds, a positive width of 3.6 milliseconds, and I've got rise and fall time there of my envelope. So that's quite an important characteristic of the 9404 SXRTO. We have the ability to make envelope measurements on RF carriers that lie within the bandwidth of the product. So this might be Wi-Fi data, it might be mobile phone data. Okay, so that's just a quick look at what we're doing here at IMS. We've got VNA on the stand. You can see we've got the synthesizers, we've got the new SXRTO, we've got the pulse generator here, and we've got our 9300 sampling scope behind me as well. We've been very busy at the show, so no doubt we'll be back again next year in Los Angeles.